Hello students. Today's first question is, if R, S and T are non-zero integers, so that these are R, S and T not equal to 0 and these are integers, right? Now, is R raised to power 5, we have to find, is R raised to power 5, S raised to power 3, T raised to power 4 negative? So, first of all, we will combine the square power. So, R raised to power 5 can be written as R square. This whole can be written as R square S and T square whole raised to power 2. So this becomes R4. So we have been left with one R. So I will keep that R outside. Now this is S square. So S over here. So T4. So this is basically this expression changes to this expression. Now inside this RST, the value of RST, since it is a square, so it is positive. This expression is always positive, irrespective of the signs inside it. So we need to find whether R into S is negative or positive. Now there are two scenarios. First is when R is negative and S is positive, okay? And the second is when R is positive and S is negative. In these scenarios, these can be negative, right? And in what, so these are the scenarios for having the answer for this to be yes, and other options are R is positive, S is positive, and R is negative, S is positive. So in this case, this expression will be positive, right? And this is for the whole expression to be negative. Now with such information, we'll move to first statement. First statement tells us that R into T is negative. RT is negative. So this means either R is negative and T is positive, or R is positive, T is negative. But from here we don't get anything about the sign of S. So we can say that the statement A is not sufficient to answer our question. Now moving to statement 2. Statement 2 tells us that S is negative. Now since S is negative, so that means, so S is negative, so it can be R positive or R negative. So even though we are not sure, so we can say that statement B is also not sufficient because we are not aware of the sign of R, right? If it is positive, then the whole expression becomes negative. And if it is R is negative, then negative into negative will be positive. And this whole expression will be positive. So since A and B are not the option, so statement D will also be not an option. No. We will check for statement C. Statement C tells us combining statement 1 and 2. Now, from statement 1 and 2, we have arrived at two values of R, that is R negative and R is positive. So R negative as well as R positive. And from the second we have arrived at S is negative. Now if this is the case, then we will have overall value as positive. And if this is the case, we will have fine. So this is like this. And if R is positive, S is negative, so this will be expression will be negative. So still we are not able to find the whether this is negative, this whole expression is negative or positive. So we will mark option E, that both statements still are not sufficient to answer our question. Each type A machine fills 400 cans per minute. Each type B fills 600 cans per minute. And each type C installs 2400 lids per minute. So we have been given the data that A fills. So this is A fills. Now B fills 600 cans. So this is per minute. This is per minute. And for C, it is doing filling, installs 2400 lids per minute. Right? Now, a lid is installed on each can that is filled and on no can that is not filled. So this is particular that C is operating on a filled can. So filling job is done by machines A and B. Right? So they are doing filling job and this is doing the covering it up with lid. Right? Now, for a particular minute, what is the total number of machines working? So we need to find what is the total number of machines working for a particular minute, and that particular minute will be mentioned in the statements. For a particular minute, total number of machines working. So we need to find total number of machines working at a particular minute. Now, moving to statement 1. A total of 4800 cans are filled that minute. Now, with 4800 cans filled at that minute, that means since 2400 are filled by one machine, so we can say that 4800 cans are filled per minute, that particular minute they are talking of. Now, with this the case, we can have 4800 divided by A fills 400. So this is basically 12 machines. So we can say that 12 machines of A plus 0 machines of B plus. Now this will 4800s are filled by 1. So we require 2 machines of C. So we can say total is 14 machines. Or I can say 24 are filled by machine A which has a rate of 400 plus remaining 2400 are filled by, so this is A, and this is for B which has a rate of 600 plus 4800 are, so C is particular, so C is, will be requiring 2 machines of C. Now this becomes 6 plus 4 plus 2, so this becomes 12 machines. Now same task of that 4800 are filled per minute, we are having 14 machines or 12 machines, so we can say that statement A is not sufficient to answer our question. Now moving to statement 2. Statement 2 says for that minute, so that particular minute we are talking, there are two type B machines working for every type C machine working. So now with this the case, we know that 2 C machines, that is for statement 1. So if we suppose that there are 2 type C machines working, right? So we can say 2 C machines are working, then 4B will be working, right? Now since 4B are working, we don't know about the, so 4B basically means 2400 machines, 6 into 4, 2400 cans are filled by machine B, and this requires 4800, so 2C is over here, so it will be 4800 are filled, so remaining will be filled by this machine, so this will be 24 also, so this will be 6B 2400, so total machines will be 12 as was in this case, and this is 6A machines. Now if let us we suppose that the type of machine working is C is in that particular minute is 1, so 1C, so that means this will be 2B. Now this can fill 2400, that means 2400 cans has to be supplied by A and B, so with this its rate, so it will be filling 1200. Now 1200 comes under this, so this will require 3A machines to fill 1200 cans, 3 machines at a rate of 400 per minute, so this is 3 plus 2, and so this will be 6 machines. So again we are getting 2 values, so we can say that statement B is also not sufficient to answer this question. Since A and B are not sufficient, we can say statement D is also not sufficient. Now we will check for statement C. Statement C says combining statement 1 and 2. Now statement 1 says 4800 cans are filled, right, per minute. Now since 4800 cans are filled that particular minute, so C, number of C machines installed to cover it up will be twice C, so this is fixed, twice C. Now since this is twice C, so B has to be single, right? If it is twice C, so this will be 4B, because from the statement 2 there are 2 type B machines working for every type C machine, so there are 2 C machines, so there will be 4B, so it is covering 4800 machines. So now since this is 4 machines, so it will fill 2400 cans at a rate of 600 per minute. Now remaining task of 2400 cans to be filled will be completed by A working at a speed of 400 cans per minute. So this means at that particular minute we require 6A machines. So 6 plus 4 plus 2 is equal to 12 machines. So this is the single answer. 12 machines are required at that particular minute, which is given by statement C. So we can say both statements combined are able to give us the answer. So for this particular case, statement C is the right option. If A and B are constants, so if A and B are constants, what is the value of A? So we have been given A and B are constant. We need to find the value of A. Moving to statement 1. Statement 1 tells us that A is less than B. So we can't find the value of A from here, since A can take any value and B can take any value, right? So we can say statement A is not sufficient to answer our question. Now moving to statement 2. Statement 2 tells us that T minus A multiplied by T minus B is equal to T square plus T minus 12. Now first we need to bring T square plus T minus 12 into factor form, or simplifying it. So T square plus T minus 12. Now we need the product minus 12 to be product and sum equal to plus 1. So this can be written as T square plus 4T minus 3T minus 12. Now 4T minus 3T is plus T, and 4 into minus 3 is minus 12. Taking T common, I am left with T minus 4, and here minus 3 common, I will be left with T plus 4. So this is T plus 4 into T minus 3, right? So now here I can write T minus A into T minus B equal to T plus 4 and T minus. Now comparing it with the right hand side, we can find the value of A. So from here I can get the value of A to either to be minus 4 and B equal to 3, right? Because this is minus A equal to 4, so A becomes minus 4, and minus B of equal to minus 3, so 3. This is the case, or I have to compare this with this. So either A has to be 3 and B has to be minus 4, right? So only these two cases arise from there. But still we are not having a single value for A. So we can say that B is also not sufficient to answer our question, and with this statement D, that both statements alone are sufficient, is also cancels out. Now checking for statement C, which says combining statement 1 and 2. Now first statement tells us that A is less than B, and from statement 2 we have got two options. Now we have to look for the option where A is less than B. So that will be the case when A is equal to 3. Sorry, has to be less than B. So that is A is minus 4. So we are able to find a particular value, because here if we select this set of values, so here A is greater than B, here A is less than B, and from statement 1 we have been given A is less than B. So this is the value for which A is less than B. So we can say that statement C for this particular question, statement C, that both statements combined are sufficient to answer the question. If X is a positive integer, so we have been given that X is a positive integer, right? Now the question asks, is root X an integer? So we need to find, is root X an integer? So basically we need to find that whether X is a perfect square or not, right? Or in other words, I can say, is X a combination of prime factors in pairs, right? Now with this information, moving to statement 1. Statement 1 tells us that under root of 4x is an integer, right? Since this is an integer, so root 4 can come out of the square, so it will be 2 under root x is an integer, which basically means since this whole is integer, that means root x is a perfect square. So we can surely say that yes, root x is an integer. Right? Only then 2 multiplied by root x has to be integer, right? So we'll say that statement A is sufficient to answer our question. Now moving to statement 2. Statement 2 tells us that under root of 3 into x is not an integer. Right? So under root 3x is not an integer. So we will take some cases. For example, let us suppose that x is equal to 1. In this case, under root 3x will be not an integer. So this will be equal to root 3. So this is not an integer, right? But under root of x equal to under root of 1 is an integer. Under root of 1 is equal to 1. So we will say that x is an integer. Now, if I take some other value for x, so if I take x equal to 2, so this becomes under root of 6. So this is also not an integer. And under root of x equal to under root of 2 is not an integer. So we have both yes and no situation for statement B. So we will say statement B is not sufficient. So for in this case, we will say that statement A, first statement, is alone sufficient to answer the question. If P, Q, X, Y, Z are different, so we have been given P, Q, X, Y, Z. So these are different positive integers. Which of the 5 integers is the median? So we need to find the median. So obviously, since there are 5 terms and all are distinct, so if we arrange them in ascending order or descending, in both the cases, the third term, whichever falls in this third spot, will be the median. Now, with this information, moving to statement 1. Statement 1 tells us that P plus X is less than Q. So P, X and Q, but there is no information on Y and Z, no info, right? So we can say that statement A is not sufficient alone to answer this question, right? Now moving to statement 2. Statement 2 tells us that Y is less than Z. So again, we are not having any information about P, X and Q. So we'll say statement B is also not sufficient. So this makes statement D also not valid. So now moving to statement C. It tells when we now need to combine statement 1 and 2. Now statement 1 tells us that P plus Q, the sum of P and Q is less than Q, and combining Y is less than Z. So we will now assume some scenarios. Now let us suppose P is equal to 3, right, and X to be 4. So let us suppose X to be 5. Now 5 plus 3 is 8. So Q, let us suppose it to be 9, because 5 plus 3, P plus X is less than Q. So this sum is 8. So Q is 9. Now let us suppose Y is equal to 10. So Z to be 12. Right? So now in increasing order 3, 5, 9, 10, 12. So we will arrange it 3, 5, 9, 10 and 12. Now both the conditions are fulfilled. P plus X is less than Q, that is 8 is less than 9, and Y is less than Z, so 10 is less than 12. So if we arrange it in ascending order, we get the values in this order. So 9, which is the value of Q, we will say Q is the median. Now we will consider some other scenario. Now let us suppose again P to be 4, x to be 6. Now 6 plus 4, 10. So q has to be greater than 10. So let us suppose q to be 11. Now let us suppose y to be 1 and z to be 3. So we need to have just y less than z. So y is 1, z is 3. Now if we arrange this in ascending order, so first will be 1, then 3, then 4, then 6, and then 11. So this is the value of y, this is z, this is p, this is q, and this is x, and this is q. So for this particular sequence we will say that 4, which is the value of p, is the median. So we are having different types of median while satisfying both the conditions given in statement 1 and 2. So we can say that statement C is also not sufficient to answer the question. So for this particular case, we'll say both the statements still are not sufficient to answer the question. We'll say statement E is the right option. If W plus Z is equal to 28, so we have been given W plus Z is equal to 28. We need to find the value of what is W multiplied by Z. Now, with this information, moving to statement 1. Statement 1 tells us that W and Z are positive integers. Right? Now, since W, nothing else has been given, we will assume some values for W and Z. Let us suppose W is equal to 20 and Z is equal to 8. So this means W plus Z is equal to 28 is satisfied. Now for this, W into Z will be equal to 20.8, which is 160. Right? Now we will assume some other values of W and Z. Let us suppose W is equal to 10 and Z will be equal to 80. So again, this condition W plus Z is equal to 28 is satisfied. So W into Z in this case will be 10 multiplied by 18, which is equal to 180. So we are getting two values for WZ. So we can say that statement A is not sufficient to answer our question. Now moving to statement 2. Statement 2 says that W and Z are consecutive odd integers. So these are basically odd integers. So odd plus odd is equal to even. Now let us suppose these consecutive odd numbers to be 2n plus 1 and 2n plus 3. So if you put the value of n equal to 1, so you will get 3, and this n equal to 1 will be 5. Right? So on. So we have been given 2n plus 1 plus 2n plus 3 equal to 28. Now this becomes 4n equal to 4n plus 4 equal to 28. This implies 4n equal to 24, or I can say n is equal to 24 by 4, which is 6. So now putting the value over here, so first will be 2.6 plus 1, so this will be 13, and second will be 2.6 plus 3, so 15. So 13 and 15 are the values. So 13 plus 15 is equal to 28, and we need to find WZ, so that will be 13.50, so that will be equal to 195. So statement 2 gives us the particular value for W and Z, and the value of W multiplied Z is 190. So we can say that statement B alone is sufficient to answer our question. So for this particular question, statement B is the right option. If A, B, C is not equal to 0, is A upon B upon C is equal to A upon B upon C, right? So we need to find this. So we will first solve this. So this is basically A by B into 1 by C is equal to A into C divided by B. So this implies this is A by BC equal to AC upon B, right? So we need to find basically whether A by BC is equal to AC upon B. So I'll write over here is A by BC equal to AC by B. So this is what question asked to us. Now moving to statement 1. Statement 1 says that A is equal to 1. Now if A is equal to 1, so this means 1 by BC is equal to C by B. Right? Now we will assume some values for B and C. Now let us suppose B is equal to C equal to 1. So in that case this will be 1 by 1 and this will be 1 by 1. So we will say yes. So we will say statement 1 is sufficient. But hold on, we will take some other values. Now let us suppose B is equal to 1 and C is equal to 3. Now in this case 1 upon BC will be 1 by 3 and C by B, that is 3 by 1. So 1 by 3 is not equal to 3 by 1, so we will say no, this is not equal. So statement A gives us may or may not be condition, so we will say statement A is not sufficient to answer our question. Right? Now moving to statement 2. Statement 2 says C is equal to 1. Now putting value C equal to 1, so we get A by B equal to A by B. So this is true for all non-zero, because we have been starting given that A, B, C is not equal to 0. So that means all are non-zero integers or non-zero numbers. So A by B equal to A by B is true. So we'll say that statement B is sufficient to answer our question. So for this particular question, statement B is the right answer. The arithmetic mean of a collection of 5 positive integers not necessarily distinct is 9, right? So that means 5 positive integers. So let us suppose the sum of that 5 numbers subdivision by 5 is equal to 9. So this means that sum of 5 numbers is equal to 45. 5 number of items, number of integers multiplied by the arithmetic mean. One additional positive integer is included in the collection and the arithmetic mean of the 6 integers is computed. So one additional member, let us suppose that member to be that was included is x, right? So now the new sum becomes 45 plus x and divided by number of items have been increased from 5 to 6. So now the question asks, is the arithmetic mean of the 6 integers at least 10? So at least 10, I have told you number of times that if at least comes, that means greater than and equal to. So this is at least. And what is at most? At most is that number or that value is the specified below that, so that is less than equal to. So here at least having given, so greater than equal to 10, that means at least this or something greater than this. Now we'll solve this. So this will be 45 plus x greater than equal to 60 or x is greater than equal to 50. So our question is basically to find whether x is greater than equal to 15. If this is greater than equal to 15, then the arithmetic mean will be obviously greater than equal to 10. Now Statement first tells us that the additional integer is at least 14. So this tells us that this is at least 14. Right? Now at least 14 means that the value will start from 14 then 15. If it is greater than or equal to 15, the arithmetic mean will be greater than equal to 10. But for this particular value it will be less than. So we are getting arithmetic mean to be less than 10 for this and greater than or equal to 10 for this. So we are getting both no as well as yes answer for with this statement. So we will say that statement A is not sufficient for answering this question. Now moving to statement 2. Statement 2 tells us that the additional integer is a multiple of 5. So now x can take any value 5, 10, 15, and for these two cases it will be having mean less than 10, and for this it will be greater than equal to 10. So again we are having no particular response from the statement 2. Now this means that statement D is also not sufficient. So moving to statement C, that is combining statement 1 and 2. Now statement 1 tells us that x is greater than equal to 40, and statement 2 tells that x is a multiple of 5. So keeping this in mind, the very first multiple will be x equal to 15, and we know that if x is equal to 15, then arithmetic mean has to be at least 10. So we will say that the statement C is sufficient to answer the question. A certain list consists of 400 different numbers. Is the average arithmetic mean of the numbers in the list greater than the median of the numbers in the list? So there are 400 different numbers. We need to find that the average of these 400 numbers is greater than the median, right? Now, if these numbers are arranged in ascending order, so since this is the number of numbers are even, so 200 and 200 first numbers divided, their addition divided by 2 will be the median, right? Now, with this information, moving to statement 1. Statement 1 tells us that of the numbers in the list, 280 are less than the average. So whatever be the average of these numbers, so 280 are below that average, right? So what does that mean? That means that 200th number and the 201st number will be below the average, right? So this tells us that the median is less than the average, right? Now see, when these are arranged in an ascending order up to 280 numbers, and these are different numbers, right? So up to 280 the numbers will be arranged, and the average is 280 numbers are less than this. So 201 and 201st number will obviously be less than that average. So this surely answers our questions that median is less than the average, right? So we can say that statement A is sufficient to answer our question. Now moving to statement 2. Of the numbers in the list, 30% or greater than or equal to the average. So this says that 30% of the numbers are greater than or equal to. So first of all, we will calculate 0.3 of 400. So this will be 10, 120. So what does that basically means? This means that 120 numbers are greater than or equal to average. So 120 numbers are having their value greater than the average. So that means if I start arranging them in this order, so 280th term will be here, and beyond that there will be 120 terms to make the total 400 terms. So this means that average lies over here, right? So 120 are greater than the or equal to average. So this again tells us that the 280 numbers are below the average. So if 280 stands over here, right? So it says 30% are greater than or equal to. So these are greater than or equal to the average. So below 20 to 80th terms will be average will be greater for them, right? So median lies over here 200 and 200 first term. So that means median has to be less than average, right? So this means that statement B is also sufficient to answer our question. So for this particular question, we will say that statement D, both statements alone are sufficient to answer the question. In a 2-month survey of shoppers, each shopper bought one of two brands of detergent X or Y in the first month and again bought one of these brands in the second month. In the survey, 90% of the shoppers who bought brand X in the first month bought brand X in the second month, while 60% of the shoppers who bought brand Y in the first month bought brand Y in the second month. What percent of the shoppers bought brand Y in the second month? So we need to calculate this. Now this is a lengthy statement question. So first of all, we will try to break this. Let us suppose the total number of shoppers surveyed, right? Shoppers surveyed be capital X, right? Now these shoppers, this is the name of the brand also. We will change it to, let us suppose it to be capital X, S. So S be the total number of shoppers. Now from this, there are two types of shoppers. First is A, which purchased brand X detergent, and second is B, right? Now moving to the statement, it says that in the survey 90% of the shoppers who bought brand X, so 90% of this, so this will be 0.9 of A, right? Bought brand X 90% of the shoppers. So if X are the shoppers who bought this brand, 90% bought in the second month, right? Which brand? So this is X brand, right? And in the first month bought brand X in the second month also. So in the second month, if 0.9A bought this, so 0.1% of those were who bought brand Y, right? This is the data for second month, right? Now, while 60% of the shoppers who bought brand Y in the first month. So those who bought brand Y in the first month, right? 60% of those shoppers bought brand Y in the second month too. So for the second month, so this will be 0.6 of B. These are the number of shoppers A and B, and total is S. So how many will be there who bought brand X in the second month? So that will be 0.4B, right? Now we need to find what percent of the shoppers bought brand Y in the second month. So basically the percentage who bought brand Y in the second month is equal to 0.1A plus 0.6B, right? So we need to calculate this, what percent of shopper, so divided by S. Or I can say, if let us suppose this sum to be equal to, let us suppose this to be C. So we need to find C divided by S, which is the total number of shopper, right? Now moving to statement 1. Statement 1 tells that in the first month, 50% of the shoppers bought brand X. So what does that indicate? This indicates that A is equal to 0.5 of S. So A is basically 0.5 of S. Now if this is 0.5, so this will be 0.5. So B will be equal to 0.5 of S, right? Now 0.1 into A, so that will be equal to 0.1 multiplied by 0.5 of S, and 0.6B will be equal to 0.6 multiplied by 0.5 of S. So combining this I will get the value as 0.05 S plus this is 0.6 into 0.5. So this will be equal to 0.30 S. So this is total equal to 0.35 S, right? So dividing it by the total, so this is S and S gets cancelled. So 0.35 in terms of percentage will be into 100. So this is 35%. So this means that the statement A is sufficient to answer my question, right? Now moving to statement 2. The total number of shoppers surveyed was 5,000. So what value this gives? This gives us S. Now since S is equal to 5,000, but we don't know how many of these are A and B. So since A and B are unknown to us, so we can't find 0.1 of A and 0.6 of B. A can be 1,000, B can be 4,000, or A and B can be equal, 2,500 and 2,500, or A can be 3,000 and B can be 2,500. In each and every case, there will be different value of 0.1 A plus 0.6 B. So we can say that statement B is not sufficient to answer our question. So for this particular question, statement 1 alone is sufficient to answer our question, and we will mark the option A. If M and N are positive integers, so we have been given that M and N are positive integer. We need to find is M plus N divisible by 4, right? Or we can say that M plus N by 4 should give us remainder equal to 0, right? Now moving to statement 1. Statement 1 tells us that M and N are each divisible by 2. Now these are m and n are positive, so we will assume some values for this. So let us suppose m is equal to 2 and n is equal to 4, right? Now m plus n is 6 divisible by 4, so that gives us a remainder 2. So this is not divisible, right? Now let us suppose some other examples for this. Let us suppose m to be 2, n to be 6. Now in this case, m plus n becomes 8, and which is divisible by whom, giving us a remainder 0. So in this it is divisible and this is not divisible. So we are getting may or may not be situation. So we will say statement A is not sufficient to answer our question. Now moving to statement 2. Statement 2 says neither m nor n is divisible by 4. So what does that basically means? This means, now let us suppose a value of m to be m or n is not divisible by 4. So individually they are not divisible by 4. So we will find in this case two scenarios in which m and n, which are individually not divisible by 4, to be, and their sum to be divisible by 4 and not divisible by 4. So let us suppose m to be equal to 6 and n to be equal to 2. So both are not divisible by 4. So m plus n is 8, and 8 divisible by 4 gives us a remainder 0. So we will say that yes, it is divisible by 4, right? Now considering some other example, so let us suppose m to be equal to 3 and n to be equal to 6. So m plus n becomes, because here there is no condition that they are, m and n are not is divisible by 4. So odd and even there is no condition. So m plus n is 9. So 9 divided by 4 gives us a remainder 1. So in this scenario it is not divisible, keeping the constraint that 3 and 6 should not be divisible by 4. So we can say that statement B is also not sufficient to answer our question, which makes statement D also not sufficient. Now moving to statement C, so which means combining statement 1 and 2. Now from the first statement we get that m and n are divisible by 2. So that means we have to consider even integers only for keeping the value of m and n, right? And second condition is that m and n should not be divisible by 2, right? So m and n, m by 4 and n by 4 should give us a remainder, right? Now we'll assume some values. Now let us suppose first is this scenario, m is equal to 2, n is equal to 6. So m plus n is equal to 8. So 8 is divisible, so remainder is 0. So we'll say that this is a condition. Now keeping in mind, we'll assume some other values. So if we assume some other values, let us suppose m to be equal to 10. We have to select that number which is individually not divisible by 4, and n to be 40. Right? Now m plus n becomes 24 and it is divisible by 4, giving us remainder 0. So again this condition is being satisfied and we can answer that m plus n is divisible by 4. Now, let us suppose dive deeper and try to have some other example. Let us suppose m to be equal to 80 and n to be equal to 22. So we need just to have an even number and it should not be divisible by 4. So again m plus n is equal to 40 and 40 is divisible by 4. So since we are getting more than 2 values, so we can say that statement C is sufficient to answer our question, that yes, m plus n, given the conditions in statement 1 and 2, statement C is sufficient, that both the statements together are sufficient to answer this question. Right? Thank you for today's lecture. If you are preparing for some competitive exam, please try to have some physical activity or physical sports or activity in your daily schedule. Plus, if you want to have your concept strong, please read NCERT books of class 8th, 9th and 10th. You can easily download it from NCERT. If you find any error in my solutions, please do comment. Thank you. Bye-bye. Take care.